Welcome to Marathon Network's PVTD Private VLAN Tool Daemon Video Data Sheet. Private VLANs are the perfect choice when implementing micro-segmentation. You can avoid endless firewall interfaces. Private VLANs are also ideal for separation in VDI deployments, allowing for segregation between B2B partners and for efficient hosting. Private VLANs provide many security and operational benefits, but they are not easy to implement and they are not easy to support. In this network, we can see primary VLAN number 10 with two community VLANs 101 and 102. We can also see that a firewall is connected to the primary VLAN. Now let's see what happens when host A tries to communicate with host B. Because host A is not on the same community VLAN as host B, they are unable to communicate directly. Any direct communication will be blocked by the network. The only way for them to communicate with each other is through the firewall. To force packets from host A to host B to go through the firewall, a manual route configuration is needed on host A. The static route sets the firewall as the next hop for packets going to host B. After the manual route configuration on host A, packets from host A to host B go through the firewall. And then, if the firewall policy allows, the packet is routed by the firewall to host B. For return communication from host B to host A, we have the same problem and the same manual solution. Now, what if our system had a central SQL server? One host is connected, then another one, and another one, and another one, and so on. For all connections in the same primary VLAN, we need to manually configure routes, both on the SQL clients and on the SQL server. Now imagine what would happen if one of the clients were to change its IP address, or if the SQL server changed its IP address. We would now have to manually reconfigure both the SQL server and the client. The server admin wants to know to which secondary VLAN a host belongs. The server admin calls the network admin. Typically, the gateway on private VLANs is a firewall. Therefore, the network admin must call the security admin to map the IP address to the MAC address using the firewall's ARP table. Then, the security admin logs into the firewall, searches the ARP table for the IP address, and then provides the network admin with the MAC address. The network admin then logs into the switch looking for the MAC address. He finds the private VLAN mappings and provides the server admin with the mapping. Now that is labor intensive, and all we wanted to know was the mapping of a host to its secondary VLAN. Host A can't reach host B. What's going on? Since the network is blocking the traffic and the traffic never reaches the firewall has no log entries. The switches also have no relevant log entries. In addition, no one knows if server A was in community VLAN 101 the entire time, or perhaps it was just moved there. This is very hard to troubleshoot. PVTD, Private VLAN Tool Daemon, is a network appliance that connects to the private VLAN network switches. Let's see how it can help you. First, we connect the PVTD appliance and configure it with the private VLAN network structure. Using an ARP, host A is looking for host B. Since PVTD is connected to the private VLAN network, it will receive the ARP request. PVTD will then kick in the ARP fixup, which sends an ARP reply to host A telling it to use the firewall's MAC address to communicate with host B. Now, host A sends the traffic directly to the firewall without any manual configuration required. Based on firewall policy, the firewall will or will not forward the packet to host B. PVTD retains which secondary VLAN the various hosts are mapped to. Given permission, PVTD's mapping data can be made accessible to all IT departments. It's now easy and very fast to identify which secondary VLAN a host belongs to. PVTD can create log entries for any host-related primary VLAN events, such as VLAN change or MAC change. IT administrators can easily search the log to find historical events and even identify configuration errors, such as hosts configured on a non-existing VLAN or a host configured with its IP address in the wrong segment. Marathon Networks makes two models of PVTD, one for 5,000 hosts and a small one for 500 hosts. Just connect, configure, and relax. Thanks for watching Marathon Network's PVTD Appliance Video Data Sheet. For more information, please visit www.marathonnetworks.com.